For the Make Ohio 2023 Makeathon, our group, Team 58, developed a heat-seeking solar panel to help better meet renewable energy needs. The problem is that solar panels are only as good as much light they receive, and there's only so much light to go around. The question is, how do you find the most light and try to generate the most power without just adding more solar panels? Now you could find the average amount of sunlight that is on a roof, or perhaps follow the average trajectory of the sun, but there's no real-time data to actually adjust a solar panel to find specifically the most efficient place on a roof for power generation. Our proposed solution was to use 3 analog temperature sensors on a solar panel and to move the solar panel around to find the highest temperature spot on the roof that would be receiving the most sunlight. There, the solar panel can most efficiently generate power. We also suggested using a mirror array. This would be able to focus light onto the roof without actually adding additional solar panels. This way, you can generate more power without actually adding more photoresistors. The first thing that our group developed was a temperature sensor. We used a 3 analog temperature sensor array in an Arduino, and were able to find real-time temperature values and even managed to measure 20% improved values after implementing our mirror array. To actually move the proposed solar panel around, which can be seen on the top rail, a 3-rail system was proposed. As you can see, this system allowed for full X and Y movement, and all degrees of freedom on a 2D surface were achieved. To actually move these rails, bidirectional motors pulling a string were proposed as the solution. These bidirectional motors were DC motors and were being powered by a 9-volt power supply using an H-bridge for bidirectionality and for speed. The actual motor pulley itself in action would pull down the rails both in the X and Y direction and push them back in accordance to the highest triangulated heat value. And of course, to improve the actual power output without adding more solar panels or additional hardware, a simple mirror array was implemented. As mentioned earlier, this mirror array had a marked effect on our temperature efficiency, and we measured 20 higher percent temperature after implementing it. The system in total can be seen here, with the brains of it being the humble Arduino Uno. Although this project was not successfully achieved macroscopically, our group is happy with the results we received on our individual subsystems. If we had more time or more resources to take this project further, we're sure that we could have came up with a fully functioning version, perhaps using stronger motors with more torque, or an actual vinyl printed system instead of using a cardboard printed system. Thank you very much, and thank you for listening.